Alright, so what if we have to take the limit whereby we have two functions? And this function, it's not that they are multiplying, it's not that they are dividing, but rather raising to the power of another function. Alright, so we take the power to be g of s, this to be f of s. So when such happens, then how do we do it? Alright, so what we do is that I'm going to introduce something to you small. Now, what we do is that you put y to be equal to f of s to the power of g of s. Alright. Then, with this, then we take the length of both sides. Watch me well. We take the length of both sides. And when we take the length of both sides, then we get the y is equal to the f of s raised to the power of g of s. Very good. Then after that, what do we do? Here, what you can do here is that then we can take the natural log of both sides. Okay? So when you take the natural log of both sides, it's going to undo for you to get the function back. So you take the natural log of both sides. Hope you can see that. And when you take the natural log of both sides, let's cancel this. So you get y, which is equal to e raised to the power f of s to the power g of s. Very good. Very good. Very good. And now, having this, you know from your algebra, please, I hope you are watching. It's interesting. Let me repeat this part. Alright, so the first thing is to put y to be equal to the both function you have. Then take the length of both sides, take the natural log of both sides, and here is what you are going to get. Now, and here is where we are. So now you know that if you have let's say x squared, alright? If you have x squared, because the x is 7 as the f of s here, and the 2 is 7 as the g of s here. Don't be confused. I clear any confusion. Alright, so with this, you know that the power will come here. So we get 2 x. So having this is the same as having this. Therefore, if you have this, it's going to be the same as the natural log is e raised to the power, then the g of s, the f of s. Hope you can see that. So that is that. So we have established that anytime you have to take the limit of a function whereby one is raised to the power of the other, what we do is that you bring the one on the power to this side, then you take the limit of the first one, alright? Then you take the natural log of it. In fact, if I'm to be you, I'll be confused to choose this. I don't want to choose this. So what I'll do is that I will go through the step. Put y to be equal to this. Take ln of both sides, natural log of both sides. You know that this is the same as this. Then you go your way. Alright? I hope it's not difficult. Thank you. So now, let's try our first question. But don't forget, what we are saying here is that this can be when you do the substitution of the limit. You can get 0 raised to the power 0, infinity raised to the power 0, or even sometimes 0 raised to the power infinity, or 1 raised to the power infinity. So when such happens, then we need, if you want to apply the L'Hospital rule, you need to be in the indeterminate form. That is why you need to apply all these things. And by applying this, you are getting closer to the indeterminate form. Because you can see something here. Forget about the E. You can see something here that here is the same as, let's say, 0 multiplying infinity or infinity multiplying 0. Because it can be that, or even 0 raising to the power of what? 0. Let's solve questions and see what I'm going to demonstrate to you. So as I said, I don't want you to cheat any formula, alright? So looking at this, let me check the question again. Oh, from the left, but it doesn't matter. I think from the left or from the right, something like that, but it doesn't matter. Alright, so let's move on. So first of all, you put y to be equal to x raised to the power x. Very good. Then you take mean of both sides. So ln y is equal to ln x raised to the power x. Then you take the natural log of both sides to undo the ln. Alright? So you can see that with this, the whole of this is the same as what we have here. We haven't changed anything. What? We haven't changed anything. Alright? It's the same thing. This cancel this. So we get y is equal to e raised to the power ln x raised to the power x. Now, we know that this can be written as x ln x. Wow, beautiful, 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 beautiful. So now watch. You can see clearly that here, we know that y is equal to this. Alright? So what we are saying is that for you to take the limit as x approach 0 from the right of this function is the same as taking 8 here. Because y is the same as this, and therefore this is the same as this. So taking the limit of this is the same as taking the limit of this. So we now move on. Very good. I hope you are now getting it. Very good. So we now move on to take the limit as x approaching 0 from the right of e raised to the power s ln x. Because that is the y. And in the y is what we are taking the limit of. And the y is the same as this. Very good. Therefore, we move on. Now here you try to do the substitution. Let's see what you are going to have. You forget about the e for now. You see that we are going to get something like, here you get 0 multiplying, 0 is infinity. So we are going to get something like 0 times the infinity. So if it's 0 times the infinity, then we need to apply our algebra. We need to apply our algebra. The algebra is that we manipulate the function in such a way that we don't change the originate. That is the original question. Alright. So, to get it in the indeterminate form, then we take the limit as x approaches 0 from the right, e raised to the power. Now watch. So you can see that I'm coming. Now you know that even before this, but it's still the same thing. This is the same as e, the limit as x approaches 0 from the right of s ln x. Very good. So the e don't even come in for now. Let's move on. So now, to apply the algebra, so we apply the algebra to be in the indeterminate form. So I want you to do something right for me here. If I have a multiplying b, is it the same as b over 1 over a? Is it the same thing? It's the same thing because this is the same as b over 1 all over 1 over a. Alright? So this is b over 1 times a over 1, which is the same as ab. AB. So for this to be the same, note that these two functions, s and ln s, is like a and b. So I can do this. Ln s over 1 over x. Hope you can see that. This is the same as this, as we have already established here. Then you can see clearly that by substitution, we are going to get here to be infinity over 1 over 0 is infinity. Wow! So you can see that from, in fact, I love this question. Now you can see that here we were in the form like 0 over infinity, but we are able to change it. We are able to change it to 0 times infinity, and we have learned from our previous video that if you have 0 times infinity or infinity times 0 or infinity minus 0, you can apply your algebra, and by applying the algebra we now have the indeterminate form. So now that we have the indeterminate form, then we can move on and apply Newton-Peters rule. Other than that, you can apply the Newton-Peters rule. Very good. So this is what we have, the e, the limit as s approaches 0 from the right. Then we take the derivative of ln s over the derivative of 1 over s. Very good. Very good. Love this question. It's going to be interesting. It's going to be interesting, right? Very good. Now, when you take the derivative of ln s, that's going to give you the derivative of ln s is going to give you 1 over s over the derivative of 1 over s is also going to give you negative 1 over s squared. Very good. So with this, it's going to be the same as, this is going to be the same as 1 over s times negative s squared over 1. And this is negative s squared over x. So we haven't yet taken the limits, don't forget. So this is going to give us negative x. So by substitution we get, so here that we can take the limit, alright? Because if you try to take the limit here, you still get 0 over 0 again. So this is going to give us negative 0. I hope you can see that. And that is going to give us 0. And any number raised to power 0 is 1. Therefore, the limit at s raised to the power of s is 1. I love these things. Very good. So let's move on. It's getting interesting bit by bit. Alright. So let's go and try on this. Let's go and try on this. I hope it's clear. The same way we are going to use to do this. The limit as s approach pi over 2, then tan s cos s, tan s cos s. Beautiful. So that is what we have. So here the f of x is representing tan x, g of x is representing cos x. Alright, so we now continue to go through the steps. So we put y, you can pause the video and try it. We put y to be equal to tan x cos x, tan x cos x. Then that is the y. Then you take the ln of both sides, which is the y is equal to ln tan x to the power cos x. Then you take the natural log of both sides. When you take the natural log of both sides, then this cancels this, so you get y is equal to that of, then this will come here. So we get cos s ln tan x. Very good. So that is what we have now. Alright? And for you to take the limit of this y, which is this, then we are saying that the y is equal to this. So it's the same as we taking the limit as s approaches pi over 2 e raised to the power cos x times ln tan x. Very good. Very good. So that is that. That is that. That is that. Then we now move on to check. Now, when you do the substitution, alright, when you do the substitution here, okay, so you do when you do the substitution here, you can see that cos pi on 2, cos pi on 2 is going to give us 0. So this is going to give, let me move on to the next step. So this is the same as e raised to the power the limit as s approach pi on 2 of cos s tan s, cos s ln, oh, very good. And now, what I'm saying is that you try to take the limit here, you end up by getting 0 times infinity. 0 times infinity. This means that we need to apply our algebra. So by applying our algebra, then we get ln tan x over, and this, as I said, you take the inverse of it, which is 1 over cos x, and this is going to be the same as this. So we haven't changed anything, but this is just going to help us to be in the indeterminate form, because you can see that with this you are going to get infinity over infinity, because this is just going to 1 over 0, which is infinity, and this one is going to be infinity. Very good. Very good. So that is that. Then we move on to find the derivative. So don't forget to always repeat this part until you are done. Then you take the derivative of the numerator as respect to s. Here the numerator is tan s, and here the denominator is 1 over cos s, which is the same as cosec. Cosec. Sorry, which is the same as sec. Which is the same as sec. Alright. So let's move on. Okay. So we move on to take the derivative. The derivative of tan x, sorry, I've forgotten something. Is ln tan x. Oh, I've done it again. Now the ln tan x is 1 over tan x. Then the derivative of the inside, which is tan x. When you differentiate tan x, you get what? Sec square. Z square x. All these over. Then when you take the derivative of 1 over cos x, knowing that 1 over cos is sec, and when you differentiate sec, you get sec s tan x. So here you get sec s tan x. Very good. And then we move on. Alright. So we move on to reduce what we have there. So this is e raised to the power the limit as s approach pi on 2. Let's look at something. 1 over tan x is cos, and cos is cos over sine. Even if you don't know, tan is sine over cos. So 1 over sine over cos, the reciprocal gives cos over sine. Then here, the sec square is the same as 1 over cos square x. All this over. So this is going to be all this over sec s, which is 1 over cos x, multiplying tan x, which is sin s over cos x. Very good. Now watch. You can see clearly that this will cancel one of these. So we get, you can repeat this part, but I want to get rid of it. Now this is sin x cos x over, here we get sin x over cos square x. Alright, so 1 over sin x cos x is going to multiply cos square x over sin x. So you can see clearly that this will cancel one of these. Then we are going to get cos x over sin x. Cos x over sin x. So that is going to be the simplified form over sin square x. So that is going to be the simplified form. I would like to clean this part. It's not difficult to get the algebra. So the limit as s approaches pi on 2, then we have cos s over sin square x. So now we do the substitution here to check if you are going to get indeterminate form again. To get indeterminate form again, then you move on to continue your derivative. That is by applying the Hospital rule. So here you can see that this is going to be cos pi on 2 over sin square pi over 2. Alright? And this is going to give you cos pi on 2 is going to give you 0. And sin pi on 2 all squared is going to give you 1. So when such happens, then we get e raised to the power 0, which is 1. Very good. So that is our end result for solving such question. Let's look at the second one. Rather, the third one. All right, so we look at our fourth question here, and if I didn't going to be our last question, I will see if I can get you some for you to go and try it. All right. You can pause the video also and try on this because what we did is just similar to this. Again, going to be interesting. Right. So cos is the f of s here, the g of s here is cos square s. So having this, we put y to be equal to cos s cos square s. Then we take the mean of both sides. Then we take the natural log of both sides also. So the mean of both sides first. Then to undo it, you take the natural log of both sides. So here we bring this to this side, so we get cos square s plus cos s. Very good. Don't forget this is argument. This is argument. So having this, then we are saying that to take the limit of this is the same as taking the limit of this. So we take the limit as s approaches the limit of. Okay, so then since this is a constant, all right, so you can see that this is going to be in such case whereby we have 0 times infinity or infinity times 0. So what we do? We apply algebra. So you just write 1 over whatever is there. So here you can see that we are now at the indeterminate form, all right? And since we are on the indeterminate form, we can now move on to take the derivative. So to take our hospital rule, that is the derivative of. Now 1 over cos squared. I'm coming. We know that 1 over cos squared is the same as tan squared, in case you know that. Because cos is 1 over tan. Cos s is the same as 1 over tan s. So you have tan s equal to 1 over cos cos s. So if here is squaring, then here will be squaring. So this 1 over cos squared is the same as tan square s. Beautiful. So e raised to power the limit. Please, repeating this exam way boring, but please, you can't get rid of it, all right? When you get rid, when you refuse to bring it, you have to change the original question. All right. So this is the same as 1 over cos s times the derivative of the inside, which will give you negative sin s. All this over. Take the derivative of this. Therefore, 2 multiplying tan s. The derivative of the inside differentiate tan. You get x squared. Alright. So having this, then the numerator is going to be sine s over cos s. Then the denominator here, we are just simplifying what we are. When you get to this side, please take your time. Just simplify it, okay? Change everything to cos and sine. Just change everything to cos and sine. And something, definitely something will cancel something. Tan is sine s over cos s times sec squared is 1 over cos squared s. So we end up getting alright, so we end up getting negative sine s over cos x times the reciprocal of this. Okay. Alright. Now watch. Let me bring the next part. This is the same as 2 sine x over cos the power 3x. So here we get hope you can see that. This cancel this cancel one of this. Okay. So if we can do it right. So here one is gone, so left 2. And then that one is just left 2. Very good. I love these things. So you see, so that is what we are going to get. So let's now move on. Just follow it patiently, you get it. Just more than one. So this, you can bring out the constant there, which is negative half, e raised to the power. Then we take the limit as s approaches 0 of cos square s, and we end up getting cos 0 squared. And this is 1, so we get e raised to 1 negative half. So this is the final answer for such question. It's not difficult, just take your time, go through, and you will love it, alright? It's just step by step. Good. So I would like to get you one for you to exercise your hands on it. Right? I'm hoping to get one. I think we have one here. Oh, that one is different. Okay, so I'm coming. I'll give you one to solve. Alright, so I give this to you to go and try. The limit as n approaches 0 of sine x raised to the power after this. Oh, is it easy, right? Okay. Let me make it nice. Sometimes you can get it like this, but you don't worry. Let me leave it to this. So take this one and go and try on it, alright? And then you know my email accounts. When you check on YouTube, alright, you go to about the channel. My email account is there. After that, you can send me your answer to check if it's correct. Alright, so just go through the same procedure and get your hands Thanks for this question. Very good. See you in the next video.